All right, let's go ahead and get started. So our plan for today is to cover limits. If you were in, I can't remember if it's on-ramps, dual credit, or both, you probably already somewhat covered these. So it should be a little bit more of just like a review. Okay, at this point of class, you should have computers put away. Okay, and then you'll have some time to kind of work on some stuff later. Okay. So first thing we're going to start with is notation. Write LIM, that's short for limit. Then X, little arrow. And then normally you're going to put a number here, but we're going to put the letter C, just to like stand for whatever that number is. Okay, then you're going to put a little minus sign. Okay, that indicates a single-sided limit approaching from the left side. Now we're going to put an f of x here. Okay, because it could be for any function, but just for our definition, we'll put an f there. If you are doing a right-sided limit, you're going to put LIM, X arrow, meaning X is approaching. You're going to put your little C, that's a stand-in for whatever X we're approaching. And then if you want to approach from the right-hand side, you're going to put a little plus. So if it's a little minus, it's from the left. If it's a little plus, it's from the right. Okay, so let me show you what I mean by that. Go ahead and take a look at problem 1A and 1B. Okay, so you have a graph of f right here. This one says that the number that I want to approach is -1, and it has a little minus sign. That means which side am I approaching from, left or right? Left. So go to -1, draw in a little divider line, and then you're going to cover up the right-hand side of the graph. And you're going to essentially just like extrapolate or use clues to see where you think the y value would be at -1 if the pattern continued. So as I trace closer and closer and closer towards -1, where does the graph leave off? What y value? -1 is correct. Good job. Okay, now from the other side, okay, notice that this is now a little plus side, which means a right side limit. Instead of letting the left side determine the pattern, I'm going to cover up the left side. And I'm going to look at what the right side's doing. As I trace in closer and closer and closer to that cutoff spot, where does it look like my y value would be? 3. Very good. Now, if those two values match, you would say that you have a two-sided limit. So a two-sided limit is where you don't put a little plus or a little minus. You would check both of those and then make sure that they match. Now, in this case, did they match? No, so you're going to put DNE. Okay, that stands for does not exist. Okay, the only way that a two-sided limit can exist is if the left and the right are both approaching the same spot. Now, one other thing I want to say before we go on. My left limit had a closed dot. My right limit had an open dot. Did that matter? No. Because remember, when you're covering the graph, you can't really see the dot anyways. Okay? So, next row. What number are we approaching for this row? What kind of 5? +5. What does the negative mean? From the left, right? So remember, if it was a negative, it would come in front of the number like it did here. So find 5 on your graph, draw in a little split. And then remember, we're only going to look at 1/2 of the graph at a time. So if I cover up the right side and I only use the left side, where does it look like my y value is going to drop off when I get to 5? 3 is correct. Now, what if I cover up the other side and I trace closer and closer and closer to the cutoff? Where does it look like my y value cuts off from the other side? Also 3. And if the left and the rights are both 3, then does my two-sided limit exist? Yes, as long as they match each other, which they do, then it's also 3. Okay. Then it says single-sided limits are not the same at breaks called jump discontinuities. Okay, so we're going to cover discontinuities more, but basically it's like a disconnect in the graph. So if your left and rights are approaching totally separate values, like they did at -1, you would call that a jump. Okay, versus in this second one, it says if you have a hole in the graph, you would call that a removable discontinuity. Okay, and in pre-cal, a lot of times we called that a hole. Okay, but really the technical term is removable. Okay. So if you want to label that in your picture, a jump is where left and rights are totally separate numbers. Removable is where they're approaching the same value, but you have a hole. Okay. Then at the very bottom of your page, can you see that? Very bottom of your page, you're going to give the definition for a two-sided limit. And all that it is that the left and the right have to equal each other. So come down here to the very bottom. A two-sided limit exists as long as the left and the right are equal. So if the limit x approach c from the left equals the limit as x approaches c from the right, then the limit as x approaches c is equal, we'll put exists. So if your left side and your right side exist, then your two side and equal each other, then your two side also exists. All right, once you have that copied down, go ahead and turn the page. All right, on the next graph, I want you to try lines 4, 5, and 6. Okay, so you'll notice it's very similar patterning. You have a different graph. Okay, you're approaching a number from the left. Okay, that's the little minus. Then from the right with the little plus, then the two-sided. Okay, y'all ask each other, raise your hand if you're confused. So drawing your divider line, minus you're covering up right side, looking only at left. Yeah. If you're looking at left, you cover up right. If you're looking at right, you cover up right. Two from the left, what do we think? What'd y'all get? Yes, good. And then what about from the right hand side? So when you cover up here, make sure you're a positive. I think you're a -2. So left hand side, we cover up here, and then where does it look like the graph drops off at? Yeah, x-axis would do it. Yes. That's okay. All right, so first one was x approach. We're gonna cover up everything's happening.
You're just now.
We're tracing your graph.
Hey, look, hey, come on. Yeah.
Okay, now use your other hand, cover up the other side. Trace. Go to there. And if your left side is 0, but your right side is 4, that's 3.
So remember the whole year.
I always have it.
Right inside she went.
I didn't write it on you. Look, that's what this says.
Oh, so far away. December 5th. Isn't that so far away? Is that your birthday? No. It just, you don't know how I could get bigger for that much longer? Is that what you're saying?
Oh.
Yeah, hopefully it won't be too long since it'll be like right around, probably it'll be Thanksgiving break and then Christmas break. Then like 3 weeks of it, you know, won't even count. Really? All right, first row. Left side limit, what is it? 0. Right side limit is? Which means the double-sided limit is? Okay, very good. Okay, as I'm approaching 0, I cover up this side. What's my y value when I drop off? Huh? At 0, what is it? Yeah, -3. What about on this side? -3. Then that means that your overall is -3 as well. Okay, what about for -6? 0. Now, if I cover up the graph like I'm supposed to, okay, with my hand, okay, remember, I'm covering up from 6 on. So can I even see what kind of circle it is? No, it doesn't matter. Okay, even though this dot is up here at 1, that's irrelevant when you're looking at limits because you're tracing the graph towards 6, but you're not actually looking at what happens at 6 because your hand is covering it. So your left and rights there would both be 0, which means your limit would also be 0. Now, f of a, okay, looking at that little recall, okay, f of a refers to the y value. And that is where you're looking for the closed dot. So in pre-cal, or algebra 2, or algebra 1, okay, if I asked you for f of -6, that's where you would report back to me where the closed dot is. So staying at -6 on your graph, how high was the closed dot? 1. So go ahead and put here, that would be 1. Okay, next closed dot I want you to find for me is f at 2. So go to 2 on your graph. You're not checking the left or the right side. You're looking for the closed dot. Where's the closed dot for f of 2? What number? Should be 4. Okay, let me show you. At 2, I see that my closed dot is on this end of the graph. So that means that determines my y value. Now, the next one asks you for 0. Okay, 0 passes through the graph at -3. Okay, but I want you to remember that your line or curve is really just a bunch of closed dots in a row. So these are all closed dots, okay, going each direction. So they don't actually have to like draw you a closed dot. If you're on a line or a curve, that counts. So at 0, what's my y value? -3. Very good. All right, for the next ones, it says write single limit statements at -3, then do a double, then do a y value. Let me show you what I mean by that. Okay, for -3, I'm going to approach it from the left. Then I'm going to approach it from the right. Okay, but really we're just practicing the notation here. That the little minus means a left side, the little plus means a right side. So go ahead and evaluate those two using your graph. -3 is right here. If I want the left side, I cover up the right side. So somebody tell me, what is my left-hand side limit or y value? 2. Okay, what about my right-hand side? 7. And if my left is a 2, but my right is a 7, my double side answer will be what? DNE. Now write it first and then we'll check it. Okay, remember that if it's a double side, should you put a little plus or a little minus? For a double, remember you should put neither one. Okay? So singles have that side indicator on them. Okay, but a double won't have a little superscript. Okay, then for your y value statement, you would put f of -3. And then you would tell me where the closed dot is. Okay, and it doesn't matter if it's on the left or the right side, or if it's totally separate. You're just looking for where that closed dot is. Where is it? 7. Perfect. Go ahead and turn the page. All right, go ahead and do all of the number 8s. That's the first 2 rows. First 2 rows. Okay, then if you did do limits in pre-cal and you want to try the 9 rows, that's fine. You want to see what you remember. But I think regular pre-cal we can do.
Oh, that's a 2.
Oh, okay. First row looks good. Okay, it looks like everyone got 1, 2 DNE for the first row. Okay, second row, what should all your answers say? -2, perfect. Okay, for the next row, it's talking about endpoints specifically. Okay, if you are at, let's say 6, I have a little minus. Which side am I looking at? Left or right? Left, very good. So I would cover up my graph, everything past 6. And if I'm covering up everything past 6, I don't even know that's the endpoint, right? What does it look like it's approaching as I get closer to 6 if I only use this half of the graph? -2. Okay, then here's the problem though. In order for me to have a 2-sided limit, I would have to have the same answer from the right-hand side. But when I cover up everything past 6, there's no graph. So what that means is these sides can't match because I only get an answer from left. So I'm going to put here for this, it's a DNE. Okay, and then I'm going to put because x approaching 6 from the right-hand side also doesn't exist. So if you're on an endpoint, okay, you're only going to have one of the limits that exists. The other side, the graph's totally blank. That means your double has to be a DNE as well, because they can't match if one of them doesn't exist. Okay, what would my answer be for f of 6? Yeah, I think it's -2. Okay. All right, go ahead and do the next one. -7 with a plus means I'm only considering the right side. And on the right side of -7, my graph exists. Where does it leave off at? 2 is correct. But if I were to look at my double limit, what would I put for that? DNE. Okay, and this time, which one is the problem? Not the right-hand side, but the Left-hand side, that part of the graph is empty, it's an end point. What would f of -7 be? 4, good, because remember, for these, you're looking for the closed dot, okay? All right, next couple, we're at 4. Looking at 4 from the left and the right, you'll notice you have a vertical asymptote, so let's talk about that. Okay, at 4, draw in your divider line. Okay, and we're gonna only consider the minus is the left-hand side. Okay, now for a limit, you're putting what value your y values are getting closer and closer and closer to. If it's dropping off at a number, you put that number. Okay, however, for this left-hand side, what are your y values doing as you get closer and closer to 4? It's a symbol. Infinity, good. If they're getting bigger and bigger and bigger, okay, then you would say it's going towards infinity. Now, from the right-hand side, we're going to cover up here. Okay, my graph goes down, 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 down forever and ever. It's not approaching a specific number, but it is approaching a specific concept. What would that be? Negative infinity. So for my left-hand side, I'm going to put positive infinity. For the right-hand side, I'll pick minus. Okay, but remember, this is a concept for bigger and bigger and bigger, concept for smaller and smaller and smaller. Now, if one's a positive infinity, the other's a negative infinity, what would I put for this? Does not exist. Very good. Okay, turn the page. All right, go ahead and try all of 11 and 12. Actually, you can do the whole page. Remember, too quick over here. Too quick.
I don't want to play.
Trevor, did you have Dodgen last year?
No, I grew up now.
Oh, so you were, and did y'all do limits last year? Girls, how we doing? Huh?
You're right.
You're
right.
Or because you're going at 6, you're going to have on both sides. Maybe it's very good.
Yeah.
But remember, you're approaching X to 6. So you would cover up, but you have to choose upwards. You're choosing. Reese, you sound surprised as you say that. Oh, you are smart. You made it all the way to calculus. Good, good. How we doing? Good, all right so far. How you doing? Okay, now for this one, as I get closer to 6, which side is that if it's a plus? Okay, so I'm gonna cover up everything past here, but remember how to trace towards. So which way is it going? And that should be, and then if you're both sides, you have How we doing? It looks like it's going great. Hold on, let me something this far. And one's down, one's down. Doing great, doing great. Okay, check your number 11. Okay, you should have all infinities for the first one and then all negative infinities for the second one. Okay, go on to number 12 if you have it already. Doing okay? Okay, now on -3, you're on this one. What is your left side? Yeah, and then your right side. Yes. You did. Okay, go ahead and check your 12 when you're ready. Okay, for 7 and -3, your left side is up, but your right side is down. And that makes your double sides D&E on those. Okay, then for the last one, for 13, did your limit exist or no? Do they match? Yeah, which way were they going? Down. So they'd both be negative infinities. Which makes your third answer negative infinity as well. Okay. At 4, if you cover up here, it's going down, and then here it's going down. Also, remember, guys, you have to trace towards 4. Towards 4. Okay? So both of these ends are pointed down. All right, go ahead and turn the page. All right, I'm going to do 7A for you. Okay? And then you're going to try the next two. So what the AP test will say is obviously it has a multiple choice section. You just pick an answer. Okay, but it also does have a writing section. So sometimes what they'll ask you to do is to find a limit, but then it'll say, if it doesn't exist, explain why. So we're just going to practice writing this answer. It's not hard. You've already been doing it. Okay, at 6, does my limit exist? Yes or no? Okay, 6 would be here. What kind of discontinuity is it? Is it removable or jump? Jump, very good. So we're going to put here, for my limit, my answer is D&E because. And then you have to go back to the definition of what makes a limit not exist. What has to happen? The left and the rights need to not be the same, right? They have to not be the same number. So you're just going to list what is the left limit, what is the right limit. My left limit, if I cover this side up, what would I get? 5, but on this side I'd get, then you just have to say that, but you have to use calculus notation. So you would put my limit, x approached 6 from the left is 5, but my limit as x approaches 6 from the right is 7. Now, if you were giving an answer like the limit is, let's say 5, you wouldn't have to do this because it says if it doesn't exist, explain why. Okay, so try the next two on this page. Okay, you're only explaining if it doesn't exist. Is that a 6-7 joke that you were making?
I don't know.
Then one more like that. Good job.
Okay, hint, your answer should be DNE because. You have a question? Okay, the first one, your left would be 2, your right should be 7. And then for your next one, what should your left and rights be for that -1 question?
Oh.
Left side should be 1, right side should be -2. Okay, I'm not going to do both of them, but I'll do the second one. So DNE because limit x approach -1 from the left is 1, but limit -1 from the right is -2. Okay, we feel like we got that? All right, turn the page. We're very close to taking a little break if you're feeling a little fatigued. Okay, so turn the page. All right, this next little section is going to be reverse limits. Okay, and the reason that I'm calling them reverse limits is that look at where your variable is for these limit statements. You have the limit answer, and you're wanting to pick what this number needs to be. So here's what I want you to do. Take a look at your graph, and I want you to find all of the places where your limit would be equal to -3, and just put a dot on your graph wherever that happens. So -3 is the y value that I want. And then I'm going to pick the x value. We'll say where it happens. So you're essentially filling in the blank in the limit statement. What x would make my limit be -3? Now on this graph, can you tell me where that happens? It would be 0. Because if I approach 0 from the left and the right, they both give me -3. So put a equals 0. Okay, next one. I want my limit to be equal to what y value? 1. I want to find all of the x's where that happens. So let's find all the places where my graph crosses 1. I have a 1 here. And then I have another 1 here. Okay, now if I list both of those as answers, okay, one of them would actually be incorrect. Okay, which of these is not a 2-sided limit approaching 1? First or second? First. Because for the first, my left side is giving me 1, but what's my right side giving me? -2, which means that this limit would not equal 1, it would equal DNE. Yeah? So basically, you can't list a break in the graph, both sides have to match. So for this one, I'm only going to list my A would have to be a 2. Okay, and then I'm going to put here not A equals -1 because both sides don't equal the y value I want. So -1 doesn't count because my left and my rights don't give me the same answer. Okay, last one like that, we're doing approaching 2. So look at your graph. Find all the places that your y is 2. So 2 is the y value that I want. I see it happens here and here. Will those both qualify as two-sided limits? Yes, and I'm listing the x's where those happen. So I would list a equals -2. And also, we'll say that's like 2.5. Since it's not like perfectly on it. Okay, so try that bottom question. You have 3 of those to try. You're listing x values to give you the limit with the answer they gave you. As long as you kind of get the idea. We're taking a break to start. So just pick the answers we want, right? Zero should have it. Should have a second one, and then your other one for could have multiple answers. But it's in your pouch. Can you hey Siri and turn it off? And what are we listening to? I can send you down to unlock. It's okay. Your teacher was like for school. Make mistakes, you know. Yeah. Sure. All right, first one. I want -1. Where about? Okay, where about did the -1 happen? We're estimating here. Okay, right at about -1. Okay, now if you put -2, fine. Okay, on your actual homework, it'll be a little more obvious. Okay, now for the second one, you should have gotten multiple answers. So draw in a line at 0, find all the places that it crosses, and make sure that you found all of them. So 0 would be the x-axis, and there are 3 places that my graph crosses. Here, here, and here. But which of those is not a two-sided limit? 5. So I would only list -7 and 0. Okay, not 5 because it doesn't approach 0 on both sides, which is a requirement for a two-sided limit. Okay, last one, I want 4. How many places do I get 4? Okay, 3, and then I also have a 4th one that doesn't count because it's one-sided. So I'm gonna keep it, keep it, keep it, and then don't want. Okay, and then we're gonna have to estimate those numbers because they're not perfect. So for that first one, I'm just gonna put -5, even though really it's like maybe 4.8. Okay, my next one we'll put 0.5, and then last one we'll put maybe 3. Okay. All right, so what you're gonna do right now is we're gonna take a little break to start on homework. Okay, some of your questions are the same, some of them are everyone gets their own. So work together on the ones that are the same. Ask me if you need help. You're logging into Delta Math for me, please. Okay, Delta Math. Yes. Sure.